meeting.
This meeting is being recorded.
Thank you very much, everybody, for joining the discussion, and a very warm welcome to Professor David Keith of the Harvard Solar Geoengineering program and various other illustrious achievements. Great to see you, David. Thanks so much for taking this time to enter a conversation with a range of interested people who've been following your work, many of us for some years, and eager to just open up conversation. So, David, I might invite you perhaps to introduce yourself, and we haven't really set a format other than we're saying we're just open to questions and answers. We've received a few questions that we can put to you, but I'd love to hear from you. Thank you.
Sounds great. So as we went back and forth by email, I don't really know what this group is, so it didn't seem appropriate to prepare anything, but I'm really happy to answer questions or have a dialogue. I recognize some people, like it's great to see Steve Stalter again, but I don't have much knowledge of what you're looking for, so I figured just some kind of Q&A is the thing that made the most sense. I will say that I'm actually, well, technically I am at Harvard physically today. That's not my affiliation anymore. So I'm moving to University of Chicago. Indeed, that is my official affiliation now, where I'm what's called the founding faculty director of a new program at Chicago that will be working on climate systems engineering. It's called the Climate Systems Engineering Initiative. And it's a pretty broad effort that will involve hiring a fair number of faculty to work on some of the issues that you're concerned about. And I think it is perhaps important marker for the field as a whole. Obviously, lots of changing, so this is just one of many things that's changing. But it feels important to me. I mean, obviously it's important to me personally, but it feels important to me for the field because all the other efforts, I think it's fair to say, have been really kind of bottom up, where one faculty member pushed to do something. So if you think of what's happening at University of Washington, I'm just talking in America for now, University of Washington or Cornell or Rutgers or the effort we have at Harvard, all those have been, come kind of bottom up thing where some faculty member thought it was worth working on these topics and convinced others, sometimes against opposition, to do that. So what Chicago's done is quite different in the sense that their new president came in, Paul Alvasaros. He wanted the university to do something in climate, which is not uncommon. Every university seems to have a climate initiative, but he really pushed for a faculty-wide committee that would really try and answer the question of what Chicago would do really unique, that would make an important notch. And one of the chunks of what that committee came up with was this Climate Systems Engineering Initiative. And so that was both kind of from the high level of the university, but with a broad interest. And then from the Department of Geophysical Sciences, there's a really high level of interest now with lots of support for this broadly, but also I think 5 different faculty members who actively want to work on this topic, not just are supportive of work on the topic. And that feels really kind of different. So the combination of that and the mandate to hire people and to, in the long run, develop a program that would link with Argonne and to think a little bit about some international aspects, that's the exciting thing that I'm moving for. I guess the biggest question to answer is what the heck do we mean by climate systems engineering? So to some extent, this is a collective thing. I mean, I'm the new faculty director of the initiative, but this gets defined by many people at Chicago and elsewhere. But I think part of it is reviving this kind of old notion of systems engineering, which I think in some ways discredited, but maybe worth pulling out. I think there's something there. There are departments of systems engineering, and I think there's some of those tools are meaningful. I think that it certainly will be broader than just solar geoengineering or whatever you want to call it. Obviously, people argue and have different names for this topic, but it will certainly include some of the cryosphere ice sheet stuff that John Moore and others have done. Indeed, there's a senior faculty at UChicago, Doug McKeel, who's a glaciologist, who's very keen on that, for example, and recruiting some younger people. And it will also include some work on sections of carbon removal that I think have the most intellectual overlap with solar geoengineering, which to me means things that involve geophysical models and public policy in complicated ways, which for me probably points to ocean alkalinity. So that gives you some sense of what we're doing.
Thank you very much, David. So our process for today will be we'll invite people to use the raise hand function in Zoom to form a queue to speak and ask questions of David. Please keep your questions brief rather than comments. And I'll kick off with one that came up for us in opening up how you see the relationship between solar geoengineering and carbon dioxide removal. Is that something you could speak on, David?
Sure, very happy to speak on it. And I can pull up some slides that kind of have explicit comparisons of risks. So very broadly, I think the four things that humans can do to manage climate risk are decarbonizing the economy, carbon removal, solar geoengineering, and adaptation. And I think there are interesting ways in which solar geoengineering and carbon removal are both very different, but have some linkages. One way to think about it is there's no question that decarbonizing the economy is absolutely ought to be the focus. But as you all know, even if you decarbonize the economy instantly tomorrow, you still have the risk of the CO2 that's in the atmosphere. So if at any given time, if you want the future either warming or some measure of kind of globally coherent climate risk to be lower in the future than they are at the time you make the decision, you have to do some combination of carbon removal or solar geoengineering or both. But just cutting emissions doesn't do that. Cutting emissions basically stops things getting worse. And adaptation is vitally important, but it doesn't change the kind of global scale impacts. So that's one kind of very high level answer. I think they are separated in a deep way in time, so that the comparison of the risks and effectiveness, if you like, let's think about the risks for a given amount of effectiveness of solar geoengineering and carbon removal look very different as you look over time. So let's say you're comparing solar geoengineering and carbon removal to do the same thing, say to reduce temperature by some fixed amount, some delta T in the future. Let's say you want to reduce temperature by half a degree C in time X. So as that time X gets to be very far in the future, carbon removal looks way better than solar geoengineering. So if that time X is a few hundred years in the future, it looks better because it's sort of fundamental dynamics that whatever the impacts are of carbon removal, and there are lots of environmental impacts per ton removed, when you remove the carbon, it more or less stays removed. There's obviously issues of ocean equilibration, but you really have undone the risk. And so you get this kind of integral over time. But the flip side of that is also true. If you make that timescale short, so I can give you some quantitative evidence, but if you compare the environmental side effects of cooling the world, say half a degree C with carbon removal and solar geo in 50 years hence, I think it's actually quite plausible to conclude that solar geoengineering is a lot less risky, because if you're serious about carbon removal, you have to really think through what the costs are. And the key thing is the damages or costs from carbon removal mostly come when you build out the system that removes a given number of tons a year. So when you build a biomass with capture facility or direct air capture facility or ocean alkalinity facility, or you manipulate some ecosystems that are going to capture carbon, all those things have a footprint, a land footprint or a footprint of environmental impact. But the day that you start them, they have no benefit. They're removing carbon, but the benefit happens only with the integral of the carbon removed, and the climate benefit happens really with the integral of that plus some time delay. So when you do the math, it turns out that when you try and use carbon removal to reduce temperatures on a short time scale, like decades or even half a century, the ratio of those risks to benefits really doesn't look so good. So I think, it's a question of what you value in analytics, exactly where the trade-off is, but I think you can generally say that the distinction between those two really depends on how far in the future you're looking. If you're looking at short-term reduction in risk, forgetting cost, obviously for cost, solar geoengineering is much cheaper. If you're looking at short-term reduction in risks, just looking at the risk-to-risk trade-off, the risks of doing something against the risk of not doing it, solar geoengineering for very short time scales looks a lot better than carbon removal, and for very long time scales, it looks a lot worse.
Thank you very much, David. That's an excellent answer. Now, on your question about what is the Healthy Planet Action Coalition, a number of us here are members of the group. We have an email, a Google group, a discussion board. We have a website, Healthy Planet, and we've put various submissions and documents, and we've also advertised your talk to a couple of other lists, the Geoengineering Google group and the carbon dioxide removal Google group, and also the planetary restoration action group. So there's a diverse crowd of people who are really interested in this question of what we can actually do. Nobody's raised their hand yet, so I'll take the chance to ask a second question. I completely agree with your analysis there on the relationship between albedo enhancement, brightening the planet as a quick result, and the more long-term sustainable results of carbon dioxide or broadly greenhouse gas removal. One of the problems that's coming up is tipping points. And I'd just be interested in your thoughts about the risk of various tipping points combining and creating a situation that makes it very difficult for greenhouse gas removal and emission reduction to be an effective cooling strategy.
There's no question that there are many processes that have hysteresis. So when you go up and come back down, you don't come the same place, or that have sharp nonlinearities. I don't think a fair reading of the evidence suggests that there are globally coherent, sharp nonlinearities where we know the values with confidence. So I absolutely understand why people want to talk about tipping points, because it's very politically and rhetorically effective to get action. But I think it exaggerates the science. I think if you read that recent tipping points paper carefully, you'll see that people have gone to great lengths to try and do something which just is able to say tipping points within the limits of, I forget if it was a Science or Nature paper, but have really twisted the science pretty hard to do that. Most of the things that are big tipping points are very far in the future and uncertain. And I think when you take that uncertainty seriously, the fact that we don't know the magnitude of these things, what you get for an overall curve of kind of overall climate risks with, say, CO2 concentration or temperature, something that rises, and it gets deeper for sure, and it gets more uncertainties to go further. So there's no question, if we put more CO2 in the air, the risks go up, and the risks go up in a way that's nonlinear. But the idea that we can just know that there's some accurate planetary boundary where we're safe inside it and dangerous outside it, I think is a profoundly false idea, and one that keeps reoccurring because it's so rhetorically effective. But it'd be great if it was true, but it doesn't happen to be true, to our knowledge. I mean, I should say, maybe it is true and we're wrong. I think there isn't evidence that it's true in a way that's coherent and clear. And the reason people love it is it seems to get away, being able to have a clear point that's just science. It has no value or cost trade-offs. Just seems so beautiful as a way to convince politicians to do something. But it just isn't the way the world actually works.
Thanks. And so one of the issues around tipping points has been that people have said that because we've got these issues like the Arctic melting and so on, that we should implement direct climate cooling very quickly. And so one of the questions that came into us was that—
What do you mean by direct climate cooling? I don't know what you mean.
Okay, that's a term that we've used as largely as a equivalent of solar geoengineering.
Okay.
So albedo enhancement and also cirrus cloud thinning is another example, but generally the albedo enhancement planetary brightening technologies such as stratospheric aerosol injection and marine cloud brightening, also mirrors for Earth, and refreezing the Arctic. Those are some of the big ideas. And one of the questions that came into us was that you're quite cautious about suggestions for rapid field testing. And so could you tell us what's your thought about the proposals to conduct field testing of solar geoengineering technologies?
I guess you have to tell me what the proposals are. I'm extremely keen on having a large number of experiments to go after a bunch of the uncertainties. So our models that we use to kind of estimate what the impacts these technologies would be have lots of uncertainties. There are both uncertainties in the model numerics, people often forget about, and lots of uncertainties in the model physics and in the model parameterizations, because there's lots of things we don't know. We find them out by observations. And that's true in general atmospheric science, but there are particular things which really matter for solar geoengineering and different for different kinds. For marine cloud brightening, understanding the probability of aerosols mixing up to the cloud base and a whole bunch of specific uncertainties. So for cirrus cloud thinning, it's heterogeneous versus homogeneous nucleation and nucleation strength of different particles. So I think there's a whole bunch of experiments you could do that would go after those uncertainties. And I think I'm very keen on doing those experiments. I think I've advocated for that for decades, but obviously you guys may have a different opinion.
Great, thanks, David. Now we've got 5 people who've.
But you used the word testing, and I think
Yeah.
you did, if I remember right. I don't know what you mean by testing.
Right. Okay. I'm sure we'll come back to these issues in other people's questions. So we'll go first to Seth Miller.
So Stephen Salter actually had his hand up before mine, and I want to tip my head to because he didn't have his virtual hand up though. So Stephen, do you want to go first, and then I'll go?
Okay. The big effort is going into zero carbon emissions, and the thing that worries me is that there's 40 times more CO2 in the oceans than there is in the atmosphere, and the balance between them depends on the vapor pressures across the ocean surface. And if you start reducing the CO2 in the atmosphere, some of it will get replaced by what's coming out of the oceans. And I don't know how much that would be, but it would be very interesting to know. I wonder if David can give his guess on how much would come back out of the oceans.
I guess I'm not sure good to see you again. I'm not exactly sure what the question is. I mean, reducing emissions, of course, doesn't reduce the amount of CO2 in the atmosphere. It just tends to stop the amount increasing. I think it's, and I must just pause for a second. You say a great deal. I like being quantitative. And I think one thing that's happened, I've been working on climate now for more than 3 decades. And I used to give a lot of talks saying it was kind of a phony war and people were talking about climate and they weren't doing anything. I think it really feels different now. The world is spending close to over 750 billion, maybe closer to $1 trillion a year on clean energy. And sure, some of it's misspent and could be done more efficiently. But you can't round that to 0. You have to round that to more like 1% of GDP, not 0% of GDP. That says that things are really happening. And you folks may have different opinions about how much money as a fraction of GDP we should spend on cutting emissions. It's worth each of you figuring out what your number is. And you can look at the difference in what we are spending and what you think we should be spending. But to me, it really feels different. The fact that we're spending that kind of money with real action to cut emissions that we did not have, say, a decade ago, let alone 2. So that was a sort of side. I think for your question, I think if the answer is if you instantaneously removed all CO2 in the atmosphere, obviously there are lots of big consequences, but it's not that hard with a model to calculate how it would grow back from the ocean. I think these there's both a combination of dynamics and geochemistry, but the geochemistry is not a big mystery in terms of just CO2 equilibration. I don't think I understand the question well.
The question is it 40 times or 20 times harder than you'd think it would be if it was only what we were doing in the atmosphere and taking out of the atmosphere? If the ocean's going to put it back in, it's going to be much harder for us to take it out.
To pull the carbon back to pre-industrial, if that was your goal?
No, I'm talking about the CO2 coming out of the oceans and getting into the atmosphere just as the bubbles come out when you open a can of Coke.
Sure, but what's the question? What's the
question is, how difficult is it going to be to reduce carbon in the atmosphere if the ocean's going to be putting it back in?
Very roughly, it's a factor of 2 times more difficult than if you didn't take the oceans, because the fraction, the ocean fraction, is roughly half. It depends on the time scale. So it's not the answer depends on the time scale.
The ocean's got a lot more than the atmosphere.
Yes, carbon, yes, but it's balanced by alkalinity.
Some of it is still
by
CO2
moles, almost all of it. I guess I'm not quite. I mean, roughly it's symmetric if you go back or forth, not exactly. So just as when we put a ton of CO2 in the atmosphere on a time scale of kind of half a century, something like half that ton is there. The same is true in the reverse if you take a ton out, all else equal.
So the background for this, Stephen, if I can just summarize the background, if we've put roughly 1 trillion tons of carbon dioxide into the atmosphere over industrial times, half of that or something like that has gone into the ocean, and we need to physically remove a lot more carbon dioxide from the atmosphere to achieve a Holocene conditions. To go back to 280 parts per million, we have to remove more than the excess. Let's move on. We've got a number of people.
Very roughly, to a good approximation, you've got to remove as much as you put in.
Yeah, very roughly, yes. Good. Let's go to Seth.
I hope you're right.
First off, thank you again for talking with us. You've
Sure.
on the area of carbon capture, you've thrown down pretty heavily on the idea that, hey, having government incentives and the profit motive is probably a great way to do a lot of the experiments that need to be done. And there's a couple dozen, 3 dozen companies that are trying to do different methodologies for carbon capture. And I think it's sort of being borne out that we're seeing a lot of really good competition and innovation that way. You've expressed deep ambivalence, is the way I'll say it, about trying to do the same thing around any sort of climate modification. And so I just wanted you to talk to us a bit about what you think are the best ways to get the experimentation, the small experiments in parallel that we're going to need in order to find the solution, if the profit motive is maybe a razor's edge.
Well, I think the profit motive is almost always a razor's edge if you're doing experiments to find out things about nature, because let me, as many of you probably know, I founded one of the direct air capture companies that's probably one of the 2 biggest or something. I don't know, and employees were about 170 now, and I don't know how to measure it, but it's certainly one of the serious ones. So I'll say the following. I think the reason that, kind of capitalism works in that case is nobody needs to trust the details of what we say. Indeed, startup companies, I don't think I'm letting you guys in on a big secret, will say almost anything to get money. That's the reality. But the thing that in the end, carbon engineering will make money on or not, will succeed or fail, I can't be sure what will happen, is on actually being able to do it, and doing it is easy to measure. So, I mean, so as you probably know, there's groundbreaking and there's, profit commitment on the first $1 billion of capital to build DAC1. When DAC1 is operational, there's no big mystery how much CO2 is going in and going out. You could have third-party accountants nail that to a %. And there's no big mystery how much electricity we're buying over the fence and so on. And there's maybe some mystery about the total flow of materials in, but not very much. And as you get more and more of these things built, the gazintas and gazoutas, as one of my electrical engineers used to talk about, are very clear. And you don't have to believe anything we say about the internals. You just have to, it's how much money goes in, how much steel and PVC goes in, and how much CO2 goes out with what electricity buys. It's an observable thing. And on things like that, I think capitalism could do a great job, because fundamentally there is all sorts of stuff inside carbon engineering. We're arguing about data. And there's a whole bunch of stuff I was involved in last week, actually. We're obviously not going to tell you that. And that kind of has an internal logic of what we believe and don't believe from whatever data. But we're not talking about that. What we're doing is building hardware that will work as it works. Solar geoengineering is utterly different in the sense that there's some little cases that's not true. In general, the problem isn't building hardware. It's knowing stuff about the atmosphere with higher confidence and removing some uncertainties about the atmosphere. And in general, I think that's a science question, not an engineering question. And for science questions like that, where the biggest issue here is really trust in the results, confidence that people are doing what they say they're doing. I think, I don't want to overstate academia. I think it's not just academia, it's national labs and a range of different things that go after it. And I'm not saying there's no role for private industry in playing some role in scientific research. Of course they are. They build instruments, they build platforms. But I think I don't tend to trust people's judgments about results when they got money on it.
So I'll just follow up.
I think finance determines a lot about human behavior.
Incentives matter a great deal.
Yeah.
how would you incentivize and organize these kinds of efforts in the absence of profit as a consensus building behavior, right?
Well, I mean, the same way we do for lots of other things that we want to achieve some social objective. I mean, for solar geoengineering, it looks like the actual cost of doing it are pretty cheap. The issue is really confidence in our estimates about what the risks are and how well we'll work. And that confidence will be, I think, driven by, open science, which doesn't mean just university science. I think it's crucial to have national labs and similar, and there's certainly roles, but I guess I think that's it. How do you get more of that happening? Because there isn't enough happening. I certainly believe that. Pushing governments to do it, providing private philanthropic funding to do it, trying to make it more international. Those seem to me like the right things.
Thank you.
Let's invite Ron Bayman.
Oh, thank you. Thank you, David, for joining us. Really, I really appreciate it. I have three. Well, they're two interrelated questions. One is a kind of a follow-up. The direct climate cooling is a broad category that includes also cooling the oceans, cooling various forms of cooling, including, of course, solar radiation management, but also many other possibilities. And that, of course, I think has become increasingly relevant as I think it's the McDougall paper on the, what's in the pipeline after net zero indicates or suggests that though the modeling that the heat will not decline, once we get to net zero, kind of stay at a plateau for at least 50 years because of warming from the ocean. So it's kind of related to what Stephen says. This is not CO2, but it's just that 90% of the warming is going to the ocean, and it's going to come back even as some of the GHG falls out after net zero. That's McDougall and Zeke.
This is stuff we've known more or less robustly for 30, 40 years. I don't think there's much new here. I mean, the inertia, this is like the Solomon paper, any of these papers on the long-term warming commitment.
Yeah. Okay. I don't want to,
yeah.
I'm just,
Okay.
yeah. So I'm an economist as you many people know. And I looked recently at the data on just the IPCC data on getting below 1.8 C. And in the report in 2009, and I have that in one of my papers, we would need to get down to 35 gigatons roughly by 2030 to have a 66% chance of staying below 1.8. If you look at and that was in 2019. Now, from 2019 to 2022, we've achieved about a 0.6% reduction per year. To get the rest of it done, we'd need 10 times that. We need to be reducing 6% every year from 2023 to 2030. I think most of us, and I look at, for example, the president of Ecuador said, give me the money, I won't drill in the jungle. Nobody gave me the money, and the drilling in the jungle for oil proceeds. So I think that the political economic problem with trying to reduce GHGs by 6% a year is pretty much insurmountable. At least, unless something dramatic happens.
Should we be doing that? Is that the right target? Is it a good target?
Okay, so the broader question is on the shaving the peak. So if we're if we're already in a situation where we're going to overshoot, it looks like 1.5, 1.8, 2, whatever the target is, wouldn't it? I think the group, many of us are motivated by a sense of just we're in a kind of disaster mode right now. We need to do something. We need to cool as soon as possible. We start with means that are maybe less uncertain, less risky, and then perhaps start implementing things, the more high leverage methods like SAI, perhaps in the poles, gradually, and see how they go and assess.
Why would you do it in the poles first?
Okay, thanks, Ron. Ron, let's just hear
okay.
From
well,
David
that would be the sort of McMartin Cornell group proposal.
What would be the reason?
Arctic amplification, and also it would cost about a third. You could start there. The stratosphere is lower. It falls out quicker. You have less of a problem with possible adverse consequences needing to shut it down real quickly.
More of a problem because you have more sulfur per unit radiative forcing, and you also have less of the effect of reducing the impact on the people who have it. You actually have less of the impact on inequality you'd like to have. So I really have trouble understanding what the ethical motivation for that idea would be. So the one thing we're most confident about in terms of climate impacts is the impacts are biggest for people who live in hottest places, and they roll non-linearly with temperature, which is the reason that climate change tends to be so unequal and fall so much more harshly on the world's poor. So I'm really puzzled about why I would apply solar geoengineering in a way that tended to shift the benefits from the poor to the rich.
As a gradual, the idea is a gradual rollout. This is a good place to start, and and that's also
that's the idea. But I'm trying to get the ethical why. Like if I start with what I understand, and I'm not a philosopher, but did take philosophy in school and taught. I started with elementary ethics and thinking about justice and thinking about risk. I don't get there. I'm not understanding the why.
You put it in the spring, and then it's effective during the summer months where it's most effective, and then it falls out by the time the winter comes. You'd have to talk to McDougall
well,
and
I know
and
the
all.
papers. I've done the same modeling too, but the issue is why. I understand the science. I don't understand the choice.
I can't speak to that. I'm not, I'm just.
But you can speak to it better than they can because you are an economist and you presumably this isn't an issue of science.
From an economic point of view. Yeah, from an economic point of view, it's a sense that we need to cool as quickly as possible, as soon as possible, in whatever way we can. And if we can do this, if we want to do it gradually, and testing while we go, monitoring, evaluating, and if we want it to fall out quickly, if we want to do it cheaply, and since the poles are warming about 4 times faster,
then don't put it in the stratosphere. But then you get even more deaths by air pollution. That paper, you'll notice, didn't go to deaths by air pollution. We know how to get a short ratio. We do what we're doing now, where we're putting still 40-some million tons a year of sulfur in the lower atmosphere, and it's killing 5 million people. Why would you want to replicate that?
No, this would be in it's in the stratosphere. It's SAI. The other, tropospheric aerosol is another option, certainly. What?
Yeah, but it's going the direction. This seems to be the opposite direction that we'd like to go. If one way to think about it is you can ask. We're now cooling the world with sulfate aerosols. Exactly how much is pretty unclear, but you can ask what's the ratio of harm from air pollution deaths from the current sulfate aerosols to the radiative cooling, and compare that to the same radiative cooling by putting things in the stratosphere. And this is the stratosphere overworld, as we call it, the high circulation, the Burr-Dobson circulation. That ratio is very roughly 1,000 to 1. So to get the same, so I feel like this idea of putting it down this intermediate world, there are other reasons to do it, but I think that you got to be clear that it's increasing the risks.
Ron, I'll just ask a follow-up.
I think I'm not sure I'm understanding. I think it is it's in the stratosphere. It's just the stratosphere is lower in the poles.
Understood. Yeah, this is a stratosphere that crosses back the troposphere by troposphere by folds. Yeah.
Some of the reasons that have been given for an initial focus on the Arctic include that there's considerable sea level rise locked up in Greenland, and also that the extreme weather that we've seen, for example, in the United States, is largely caused by the disruption of the jet stream. What do you think of those points, David?
The second one is, well, the first one's certainly good, but remember, if you do more global stratospheric aerosols, you get polar cooling and amplification still there. The issue is, do you want to accelerate that even more and try and overcool the poles, increasing the pole to equator gradient, which all else equal will strengthen mid-latitude storms? At least that'd be your first order expectation.
I think it's strengthening the stability of the jet stream. So, greetings, David. To answer the question of why, I think we're looking at imminent loss of sea ice in the Arctic. This is an attempt to reduce the rate of sea ice loss in the Arctic. and also an attempt to stabilize, let's say, the climate in that portion. There are some arguments that there's less oscillation of the jet stream when you've got a stable cryosphere. And you mentioned the need for cryosphere work. This is really towards the direction of, can we stabilize the northern polar cryosphere?
Well, it's a point of view.
Yeah. Oh, no, I mean, I think it's
Yeah.
actually an open question. And I think one thing that's helpful, people have been thinking of stratospheric aerosols monolithically, but I think John Nissen and others have brought up the point that stratospheric injection north of 60 degrees north results in there's an average circulation that's going towards the pole and then descending. So there's an argument that polar or Arctic stratospheric aerosols actually has a shorter lifetime than the 2-year typical lifetime that's been discussed.
Yeah, that's definitely true. Yes, why that's a good thing, I'm mystified about.
Oh, well, the notion is this. I mean, there's a hazard, and that is ozone depletion in the late winter and early spring. The opportunity is to include improve reflectance during the spring and summer when you have the greatest insolation. And then
some of that effect, but you get a lot more aerosols raining.
Yeah, about a 6-month time scale. And then the objective is to find places where this is decaying on a time scale of months rather than years. Then you've got a decent chance of keeping your ozone and a decent chance of affordably stabilizing the Northern Hemisphere climate potentially.
I don't think affordability is the big issue. I think I'm just not quite getting it.
Okay, well then let's not talk about affordability. Let's talk about scalability on a climate relevant timescale. I mean,
what's a climate relevant timescale for you?
Years rather than decades, perhaps. I mean,
what would you propose that we do? Like, how quickly would you like to see 0.5 degree of cooling or so many watts per square meter of cooling?
I would frame it the way James Hansen has framed it and Bill McKibben, and that is calling for the research to be done on rebrightening the planet and actually getting us back to, let's say, climate stabilization, because it's clearly not stable with respect to Arctic sea ice, at least. So that's, I mean, it's calling for the same research.
Sure, it's unstable, it's just warmer. For Arctic sea ice doesn't have much hysteresis.
Well, let's talk about instability.
The big glaciers have hysteresis, but the sea ice doesn't have so much.
Well, so
first
of all, the multi-year ice is gone, so there is hysteresis there. I mean, there's a multi-year memory with respect to the multi-year sea ice. The volume is down maybe 60–70% in terms of Arctic sea ice. Okay, so the point is, it's unstable in this way. There's a runaway feedback loop, and that is once the albedo of the Arctic is 0.2 instead of 0.8, and you've got more insolation at the North Pole than you do at the equator during the summer, you're now looking at a situation where the heat input to the Arctic is substantially different than it was when you had perennial ice or year-round ice. And so that means you're going to have continued heating, which has enormous ramifications for submarine permafrost methane release, for example, from shallow areas, whether it's the North Slope or Siberia, the Siberian Arctic. So we're dealing with instability that is associated with the loss. I mean, just the fact that we're going to lose ice, in the late autumn in the coming years, if not decades, presents a form. It's an unprecedented climate situation. So the question is, could we stabilize on a time scale that would prevent the loss of perennial sea ice in the late summer?
Okay.
And so those are the questions. I think this is very much along the flavor of the 100+ scientists who have signed the request for doing research on, rebrightening, let's say, the albedo of the planet on an annual timescale. And that's a growing number of scientists. And I'm very interested in your thoughts on how do we do that. And I think the comments that Ron may have made and others are in the direction of how can we promote the modeling and incrementally scaling research that can lead to informed operations on a timescale relevant to the climate crisis. And I think that's a key question. We're really interested in your thoughts and insights on that.
Well, I think this hangs on maybe different assumptions about the timescale. So I think that you think that things need to be done in years, it sounds like. And I don't see a time scale of years.
Mhm.
So I do want to see much more aggressive research on solar geoengineering broadly,
Sure.
all the way from space shields through to surface brightening, so we understand how these things work, how to apply them, what their risks are. I think that's really important. I think there are strong arguments for beginning slow deployment relatively soon, but I think there are arguments you can make on a kind of intellectual but not politically pragmatic basis for beginning it in a decade. But I don't see this kind of crisis at the level of a year or two. I think a fundamental fact about climate for me, but maybe I'm wrong, is this kind of slow moving thing where the risks accumulate with time, and they are getting worse in ways non-linear, but there isn't a sharp threshold. It's not like an asteroid coming towards the Earth, which is why it's so hard to get political action.
Yes, that's true. We're boiling frogs slowly. And I think the question is, certainly in this group, we're looking at a situation where there are multiple tipping points. Arguably, Antarctic ice is already at a tipping point or beyond it. We have seen dramatic loss.
So I think it's important, just like, I can't just let that go by. I don't think there's strong evidence to support that. That might be true, but I don't think there's strong evidence to support that. And I feel like I got to say, I'll tell you this, when I talk to people in the kind of, and maybe obviously there are times where the kind of elite people who published a lot are wrong, but time and time again, I just gave a big talk at Princeton a few days ago, and I had a bunch of conversations, dinners and over beer with some of the people who are rated as some of the top climate scientists. Almost all of them have a feeling that there's this disconnect between the crisis that students see and what they see. And I think my view, there's some of things I say that are very much not common wisdom and are far outside the norm. But my view that tipping points are a kind of grossly overstated thing, I think, is the mainstream in the climate science community.
That's an interesting question. So your impression is that tipping points are they're overemphasized. Is that what you're saying?
Vastly. I mean, Granger Morgan and I took our names off one of the very first of those papers 15 years ago because it wasn't able to kind of deal with basic questions of, vastly and deliberately. And for good reason. I give you the social science reason why it's true. I mean, go way back. One of my first times I ever got to talk to a senior policymaker was I was a postdoc at Princeton, and Paul O'Neill, who at that point had been CEO of Alcoa, and he was going to be Treasury Secretary. He knew we did climate stuff. He came to our offices and said, like, just tell us what target to aim for. Kind of technocratic thing, which I love. Like, tell us what the number is. Well, then we'll look at policy, right? And there's some beautiful social experiments that show it's much easier to get agreement if there's a sharp threshold, you don't know the magnitude of the threshold, compared to when you don't know where the threshold is. There's a beautiful social science experiment like that. So there's a lot of political insight that says if you just had a sharp threshold, it'd be easier to get a deal. But scientifically, I just don't see that. I mean, I'm not an expert, but I'm a reader, and I talk to the experts on Antarctic cryosphere, and I see huge spread of uncertainties about where these nonlinearities are. And also remember, the extent of these nonlinearities, they haven't explored what happens if you cool it down later. Something we'd like to do, but guys who explore that. But the idea that you can say there's a tipping point and we passed it, I just think it's a political statement. It's not a technical statement, because I don't even know what a tipping point is technically.
Well, I'm glad you brought up this.
Brian, what we'll do is we've got a number of other people who've got questions, and that I'd love to keep this conversation going.
And I've got to get off. I thought we had an hour. You've said it for an hour and a half. I think I should get off in 15 or 20 minutes, but I had no idea what this group is. I'm happy to do this again. So that's one way to think about it.
So we've just got 15 minutes with you, David. Is that right?
Yeah, call it 20, but yeah.
Okay, thanks. Well, we'll go to Gregory Slater.
Yes, this is Greg. Can you hear me?
Yes.
Yes.
Thank you, Dr. Keith. I want to come back to your why, philosophical or whatever, which is, there's been some discussion about experiments with SAI at the pole. My motivation, or my desire, is to see what I would call the first Antarctic pulse test, not as a deployment, not measured as its efficiency against lower latitude, but purely as a means of testing the models, which is so crucial. So here's what I propose, and maybe people have talked about this exactly, but you essentially charge the below 60, the polar circulation cell over the Antarctic for a month with enough or so with enough SO2 to predictive or to believe with the prediction that that much will lower the temperature by some amount that you predict. Now, beforehand, you do say multiple codes modeling as on supercomputers, and you say this is what's we think is going to happen. You do this, you then let it decay. Now you have it very well instrumented, and there are varieties of ways to do that. So you can measure good instrumented thing, and you measure all these things. You measure how it leaks into the adjacent convection cell. You measure everything. So, and then it's gone, and nobody knows it ever happened because you can't detect it afterwards. So my why is not it's more effective than down up further away or anything like that, or economics. It's we do this, and I do not see the horrendous resistance to doing a one-off test like that. Now, pending the outcome, if it doesn't show these catastrophes that everybody's scared about, you do another test, and you do it like you're actually like any kind of a technology you're trying to develop, because you have to do it.
Okay, Greg, let's hear David's response, please.
Okay.
So I agree with the spirit of that, and I'd be quite supportive of a bunch of things to test, but not testing temperature response. Because of the way temperature integrates, it's extraordinarily hard to see the temperature response for a short pulse on reasonable timescales, whereas it's quite easy to see the radiative response. So I commend you a paper that Doug McMartin and Ken Caldera and I wrote called "Can We Test Geoengineering?" that deals with this kind of fundamental question. It's an old paper, but I think the physics of it is really simple. Like even if you did large scale, like kind of many watt per square meter solar geoengineering globally for a year or so, it's actually hard to detect any signal in surface temperature response, because, let alone in a smaller area, because of these kind of basic signal to noise and 1/f spectral questions. So I think your science needs to go after where the uncertainties are. There's actually not much scientific uncertainty that if we reduce radiative forcing by a certain amount, that will cool the planet. The uncertainties, in my view, are uncertainties about how much radiative forcing, what for stratospheric aerosols, and uncertainties are about what the effects of those descending aerosols are in the upper troposphere, for example, what the size distribution of particles is, some chemical effects we're not sure whether to expect or not, the fact that aerosols in the stratosphere aren't just sulfate, but they've got various organics in them, that you could test. And I think there are ideas of things that would be not just small experiments, but larger tests, but they go after the stratospheric response, and then you'd measure the aerosol size distributions and be able to infer accurately the radiative forcing, but you wouldn't just go measure the surface temperature. I get why that seems like the natural thing to do.
Let me, because
Sorry,
I
Greg,
understand.
We'll
let me
move
just
on, Greg. We've just got 10 minutes with David, so we've got a couple of other people who want to speak. So we'll ask Charles Dermler.
Hi, David. I'd love to get in touch with you and talk to you for like a month. I've been, I heard about all of your problems with scientists and people just treating you like crap. And I've got the same viewpoint on people. I've tabled the solution of controlling hurricanes to make clouds to reflect the sun's rays out into space, cooling down the planet. 7 times at the oldest and largest environmental law conference in the world. Everybody complained that it doesn't reduce CO2, so I developed a way to sequester 200 billion tons of CO2 a year, and I'd really love your help. Anyhow, just like we have 48 billion square kilometers available to plant seaweed, you need 35 billion to grow enough to sequester 200 billion tons of CO2 out of the atmosphere. Put that down on the ice near the Arctic Circle, where there's 4 months of nighttime. Then you go.
Let's have a question, Charles, please.
How do you get people to listen to you and to stop ignoring you, interrupting you, and treating you like crap? Because, you know, I'll forward you my information.
David, what's your answer?
Yeah, I don't have I mean, I don't think I've necessarily done the best job, but I think when I or other people are doing it well, it's by hearing questions respectfully, even when people really disagree, and to try insofar as we can to explain the facts with the uncertainties we have, admitting that we don't know stuff, and to separate facts from values, to sort of say something about what our values are and why, and what we see the facts are and why, to kind of tell a story that's complete and respectful, and to try and engage with people's questions.
Wow. Yeah, it's hard to get that respect.
Yes. Okay. So let's go on to Herb.
Thank you, Robert. My question, I think we would all agree there's 3 or 4 major objections that are often brought up against solar geoengineering: termination shock, unanticipated or unknown adverse impacts, and so forth. But one of the ones that gets a lot of the attention is the challenge of governance. And I'm sure you're probably more aware than anybody of the difficulty of getting approval under international laws and regulations. And there's now, you've got the most of the activist community vehemently against even doing research. You have the non-use agreement for solar geoengineering that has several hundred signatures. So I guess my question to you is, if you could take just a couple minutes to describe what the process might be ideally or realistically, however you'd like to characterize it, to get from here to there to where we have a effective governance regime within a certain period of time, and what that end state might look like. What are the institutions and so forth? So anyway, I'll stop there.
That's an easy one. But let me start with the first kind of assumption there, and I'll get to your later part. But I think there's a way in which things aren't as bad as you see them. So not trying to pick apart exactly what you said, but you sort of said all the activists. I think what I see is there is certainly some group of very articulate and effective people who really oppose research on solar geoengineering, like the ones you mentioned. But they're objectively a pretty small group. And the mainstream environmental groups that have a lot of power to shape policy are mostly being pretty careful or picking middle positions, and that's what they're communicating to policymakers, and those positions are shifting, which is profoundly important. And from the extent to which we have evidence of what regular people think by polling, and also evidence of what scientists think, they suggest that, in fact, a very strong majority supports research. To the extent that we know that for scientists, just as an example, we did a paper that we randomly selected US IPCC authors and more or less randomly selected Chinese ones, and essentially they all supported research, and those are IPCC authors. And there's a similar one that Astrid Dannenberg did of climate negotiators. So I think it's important when we talk to people, I say, don't believe me, I'm just one person. But when the press comes to me and says there's so much opposition, I say, well, what do you mean by so much? Here's the objective data. The answer is there's a small group, they might be right, can't prove that they're wrong, but they're small. And the many different established scientific societies have called for research, and there is more research happening. So I do think that's important to not overstate where that's coming from. I also think part of the rise of the efforts of the non-use agreement are partly coming now because in some sense they see they're losing that argument, because in fact the interest in research has grown very strongly, and you see that in all sorts of ways, and not just in this country. And to be clear, we still don't have anywhere near as much research as we should, but the direction where it's going is changing pretty quickly, I think. As to what an international architecture should look like, the short answer is I don't know. I think the most important thing is that we begin to discuss it in a serious way. And one of the things that I'm involved in that's most exciting is this Global Overshoot Commission, where I'm one of the people who serves as me and Ted Parsons serve as so-called special advisor, secretary, or whatever. We're not on the commission, but we've seen the whole thing inside, and we are helping it do whatever it wants to do. But that is by far the highest level political group ever to engage these topics. To be clear, it's looking at carbon removal and solar geo and adaptation. Basically, it's looking at things beyond emissions cuts for overshoot. And I think it's important to say that the conversations that I've heard in that table, obviously I can't relate what specific people have said, but you could look at who's on it. There's 4 ex-heads of government, for example. Those really sound different than these conversations. And in general, when you do talk to senior political leaders who are used to dealing with high uncertainty and difficult things, they don't sometimes see solar geoengineering as hard as people on the inside do. There's a way in which people who are looking very close see this as some giant thing, but people whose job it is to deal with all sorts of things, with wars and epidemics and economic crises, they don't see this typically as so black and white. And so I think the important thing is to talk about it. I think that we're never going to get, nor do we need, some kind of international formal thing that requires unanimity, because that's not how international affairs get decided. We want to discourage unilateral action. And I think the plausible pathways are most likely coalitions of countries. And the issue is about what are the terms for organizing those coalitions and how the international system reacts.
Thank you.
Let's go to Peter Fikowski.
Yeah, I was just going to say briefly, we did have Jesse Reynolds speak with us some months ago from the Pursuit Commission.
Okay, thanks, Herb. Peter?
Yeah, David, it's great to see you again.
Good to see you.
Yeah, thanks. It's been a long time. So you mentioned facts and values. And in the work that I'm doing, I often use this distinction I call a safe harbor. Now, this is regarding to CO2 levels, not so much temperature, but the two are highly related, of course. And it's wondering, from your position, we talk about a safe harbor, which is, the story is a ship in stormy seas goes to the nearest safe harbor where the ship and the captain have been before. And the captain will usually not go somewhere strange and hope that the ship will survive. And similarly, with our children and planet, we want to go back to CO2 levels that actually allowed us to develop agriculture and civilization, which is 280, and the highest level is 300.
Let's have a direct question, Peter, please.
Yep. And so the question is, does that qualify for you as a value or a fact?
Well, I don't think it's a fact. That's pretty clear. So we said we want to go back. So I don't think it's true that that's a widely shared view. And I don't think you have objective data to say that. I'm not aware of good polling that shows that. I don't think it is. You and I have talked about this years ago, and obviously I think you decided that you didn't agree with or didn't want to listen to me, which is probably why we haven't talked so much. But as much as I would love to say there was an objective, I think you sort of are implying that there's a box where you put in science and sort of you turn a crank and there's an answer about what is the safe CO2 threshold. And I just don't think that's true. If you're talking about kind of safety in terms of, can the planet survive? Can humans survive? I don't think there's any problem with the current CO2 level or a higher CO2 level, frankly. If you ask me personally what I want, I care a lot about having the world the way it was for my kids. And I would love to really reduce climate change. And I have a bunch of reasons why I think that's important. But I don't think that's because it's just true. And I think a really important thing, I think a beautiful thing, I'd be happy to circulate the excerpt to you folks, was the thing that Oliver Morton wrote about not using we in his very clever book about climate engineering. Because it's so easy to say what we want is if everybody agrees, but the whole essence of the problem here is that there's a lot of different people on the planet and they have different viewpoints. And you can't be sure, nor can I be sure, that our viewpoints are right or wrong or widely shared. And I think the answer is there are really different views. If you want to maximize agricultural productivity and you don't care that much about the details of pre-industrial, the right answer might be even higher CO2 concentrations plus some solar geoengineering to flatten out the polar equator gradient. I think the answer is it's value driven. What the answer is, there isn't a single answer.
Thanks. Let's hear from Jonathan Cole.
Hey there. Yeah, I've been a supporter of stratospheric aerosol injection since it first came on the scene as a scientist. And but what I've decided to do is due to my finances and my skill set to work on ground-based mirrors. But every one of these versions of solar radiation management have a knee-jerk reaction from both politicians and regular people. For ground-based mirrors, for instance, it's well, won't that blind the pilots? And then I have to handle that for half an hour. And I think in the case of stratospheric aerosol injection, it's about a acid rain. And so when I talk to people about it, I have to handle their issue on acid rain for half an hour. What's your current best brief handling for the concept of everyone's going to get burned up by the acid rain?
That one feels like one of the very easiest and one that I don't hear very much. There's a sort of simple empirical answer. Acid rain is really just proportional to the total amount of sulfur we put in. We used to put 100 million tons a year in the atmosphere, back more like in the 70s. I like your plot. We now put in under 50, and it was a concentrated sulfur emissions that caused big acid rain. And you could do, assuming you're doing some strategy where SAI is one part of what you do, you could do a lot of cooling with huge benefits if you're clever about it for something like 1 or 2 million tons a year. So that would be 1 or 2% of the acid rain we had in the 70s, and it's global. So in fact, it's much less concentrated. So I think that's really clear that there's not a big risk. There have been several papers that showed there's not a big risk. And I think we have this very strong empirical evidence. And when I explain that with simple numbers, I feel like everybody I've ever talked about that says, yeah, you're right, that's not a problem.
So what are the biggest problems, David, that you encounter?
The biggest problem
for stratospheric aerosol injection proposals?
What I think are the biggest technical risks, or
no, what you perceive as the biggest political problems that people raise in the line of what Jonathan commented.
Biggest political problems people raise are the difficulty of getting any kind of stable agreement, and the idea that any of these things will reduce the pressure to cut CO2 emissions.
Okay, let's hear from
that latter one, the moral hazard, is the biggest underlying concern. I think that's reasonably clear.
Yes. Doug Grant.
Thank you, David. We could probably spend another half an hour on my question, but I'll keep it simple. ScopeX had a problem last year. Do you plan to revisit that type of a test? And how will you deal with people like Tom Goldtooth, ETC, OSA, Larson, Blind, and people like that? You have you thought about that? Excuse me.
Frank Koich's lead. He and I are actually having dinner tonight to try and talk through and make decisions about what might happen. I think I can think of quite strong arguments for canceling it and quite strong arguments for continuing it. In the end, it's Frank's decision. I do want to slightly restate what happened in Sweden. At least everybody has their own view of what happened, but I don't think fundamentally the issue was that the, say, Sami Council disagreed. I think they had every right to disagree. No problem with, I don't agree with what they said, but I have no problem with what they said. I actually do have a problem with what the Swedish government did. So there was concerns raised, and the Swedish government, my understanding is against the Swedish constitution, but I don't know that for sure, but that's what SSC said. The Swedish government told SSC, the balloon operator, to stop, which my understanding they were actually not supposed to do. And I think in a democracy, when something that is otherwise legal and gone through all the procedures is moving forward, and somebody says you shouldn't do this for some reason, you should listen, but then you should say, we're going to have some kind of public inquiry and have a process that comes to a decision, hear different points of view. And the Swedish government chose not to do that. So if I feel a little bit pissed off, I'm actually not pissed off at the Sami Council, because they've got to do what they got to do. I think in a democracy, I want people to be able to raise objections, whether I agree with them or not. I do have a problem with the process the Swedish government used to deal with that. And so I think, well, it's pretty clear I wouldn't try it that same way in Sweden, or we wouldn't try it that same way in Sweden again. Obviously, I think in the US, that's less likely to occur because there's less opportunity for political leadership to just stop something that otherwise is legal and permitted. But that still doesn't answer the question of what's the right thing to do and what are the trade-offs. So there are different views about how useful the experiment is. I think bottom line is, I think Frank and I, have undersold the utility of the experiment to the scientific community. I think there's actually more there than the scientific community thinks. And the CLIN clearly kind of has a bad brand. And so it's not obvious what we should do.
Let me ask one question. Is it possible we could talk?
I think I realized I wanted to add on. To me, ScopeX is one of like 30 different things like this you could do. There's a whole bunch of these that are worth doing. And the issue is how to get that whole set of things to move forward.
I'd like to continue this. Can I talk to you by email? Can you share your email with me?
My email is public, but I'm pretty busy right now, but feel free to email. Yep.
I can keep it very simple. Okay.
Yeah.
Look, we'd love to continue the discussion further, David, and thanks so much for your offer to come back and have a repeat session, and let's be in touch about scheduling that, because I think that's been a really fertile discussion. Now, can you take one further question?
Sure, but let's think about, so I'd be happy to, because it's interesting to talk with different groups. I've seen little emails from this group. I haven't quite known what it's doing. I think there's some places where I think, obviously this group has itself got lots of diverse opinions, but the extent that there's some kind of general ideas in this group and there's disagreements, maybe I'm happy to go back and forth with you, Robert. Maybe we kind of narrow it down to one or two things and have something a little more like not quite, I'm thinking about Oxford debate, but we like narrow it down to a question or two and really pick up on those. And I'd be happy to do that. And you could also do me plus some other person. So I'm certainly open to do something like that. Yes, sure. Happy to take one last question.
Thanks very much, Daphne.
Thank you so much. It's great to hear from you, David. Two quick comments. One is, I'm wondering, what I had heard is that the Sami people had not been consulted and given their free prior informed consent prior to the test happening. So is that the case, or is that not the case? And then the second question is, have you explored methane removal as one additional tool in the toolbox, and especially at the level of the Overshoot Commission?
So we reached out to the Sami Council and to various Swedish authorities. The Sami Council strenuously avoided talking to us. I think that's because then they want to be able to say that they didn't talk to us. So I regard that as a bit of gamesmanship. From our perspective, we're very keen to engage in SSC, which has Swedish Space Corporation, which operates in Sami land and has a long engagement with the Sami. We're also happy to engage. So obviously it's very effective for them to say that, but I don't think it's an entirely fair representation of what happened. The Sami Council itself represents quite a few different Sami people and has complicated internal politics. I think part of this stuff had nothing to do with solar geoengineering. It has to do with disputes in Sami land about mineral exploitation in the Sami part of Sweden, and disputes with the government about that, and the government wanted to just not get into anything given those ongoing disputes. So the short answer is I am very happy to have consultations. We were trying to do that, but I think this is we were politically outmaneuvered because it looks very effective to say that we didn't want to consult, but I think that is the opposite of the truth from my perspective. I think
It's
methane
actually
removal really hard, and methane has it's only got a 10-year lifetime. So I've never really seen the point of trying to do methane removal, but maybe I've just been, methane removal for some situations of like mines where you've got several percent coming up can make a lot of sense. But I think methane removal for the atmosphere feels to me like it's just hard to imagine doing it at an interesting price.
okay.
Better to deal with the sources. That way it's so different from CO2. Sorry, just to say that, because it's got this short lifetime, the benefit of removal versus dealing with the sources, it's like, why not just deal with the sources? CO2, you really do have this long lifetime. It's a different problem.
Clearly, it's a different problem, but 40% of methane comes from so-called natural sources, which are rising. And the studies I've seen suggest that it's going to continue to rise for quite some time, which creates its own feedback loop.
Mm-hmm. It contributes to the feedback. Yes, that's true.
Mm-hmm.
But for many of those could be dealt with by the things you're talking about. That is, the point is you could deal with, say, permafrost carbon and methane by reducing temperatures by solar geosharing of various kinds.
Yeah, I think this notion of a short lifetime it ignores the fact that methane levels are stable and rising, and the instantaneous value, of course, is up around 120 or higher. So its contribution to warming today is substantial, and it's of course 3 or 4 times the level as it was pre-industrially. So it seems like certainly the second most important greenhouse gas. So it's fine to talk about extinction, but when you're looking at rising levels in natural sources and the possibility of runaway feedback loops, methane looks a lot more daunting, I would say, from that perspective.
Maybe.
Okay,
Well,
well,
thanks so much, David, for joining us. Really appreciate it. And
thanks a lot.
Okay, bye.
And I should say, thanks to all of you for paying attention to this crazy topic. Like, this is what we need. It's never going to be that everybody should agree, but actually engaging is what we need. So thank you very much. Thanks for your time.
Great to see you.
Take care. Bye-bye.
Okay, speak again. Bye-bye. Now, we've got the the opportunity for further reflections on that. So if anybody wishes to comment, we'll keep the discussion open for another 20 minutes.
I would like to
Yes.
have talked a little bit more to ask a proper question rather than being shut up after 30 seconds. I mean, we both have solar radiation management projects. Both have been treated like crap for 20 to 30 years. Me and David has a lot in common, and I wanted to, you know, it really hurt. I'm disabled and have a lot of mental problems, and you know, you're going to miss out if you just ignore me and treat me like crap.
I'm sorry, Charles. We had I wasn't aware that David needed to leave after 60 minutes. We had asked him to stay for 90 minutes, and so we were time constrained. So I apologise for constraining your question. Thanks for raising that, Rebecca.
Hi everyone. I enjoyed listening to that, obviously, and what I heard him doing was starting off with questions like statements like we're not very close to tipping points. I agree that it's not a black and white on off situation with tipping points, but my question or comment is, can we try and summarize what he said with both larger statements, and he also had a lot of interesting detail there, for example, about marine cloud brightening and why he thought it wouldn't work, which I didn't understand or might not work. I think to let this go to waste would be a shame, and can we spend the time reflecting on it if we want to invite him back so that we're getting more out of him next time? And also I think it will help our own advocacy efforts.
Yeah, that certainly makes sense. And yeah, he certainly challenges a few of the assumptions that our discussions in Healthy Planet Action Coalition have raised about tipping points. And so there's that challenge to say, well, what is the scientific opinion? And yeah, very diverse.
Actually, I think this tipping point question, it reminds me so much of the IPCC over conservatism. I mean, I think if we do our homework a bit, we can articulate multiple tipping points. And, you know, maybe the word tipping point is something we just want to reframe with David. But the reality is that the runaway feedback loops that have been present for 3 decades and are present today, I mean, loss of sea ice and a change of albedo for a significant portion of the Earth from 80% to 20% is a huge change that doesn't stop when the sea ice disappears. You keep getting warmer, we keep melting submarine permafrost, and we're going to have how many thousands of gigatons of methane potentially entering the atmosphere? I mean, we just look at the Permian mass extinction as an example. And so I think we just need to frame it in a way that you know, David can listen well to it and respond to it. And then secondly, talk about these runaway feedback loops that are clear and present today, and get us, you know, informed opinions on these. It's helpful, but I think some of the conservatism sounds like an echo of the IPCC to some extent. And we know that IPCC has systematically, you know, underestimated sea level rise, underestimated near-term climate effects in so many ways. So we just need to, you know, frame our questions a little bit better, and then I think it'll be great to have another session to really investigate those questions of runaway feedback loops more precisely.
Can I respond? Thank you.
We can't see you, Greg.
Okay, well, I'm sorry, I don't have my video on, I apologize. So on tipping points, when the important thing about tipping points is like, you know, the 1/e, if it's an exponential thing or whatever, I mean, or the exponentiation. So you can have a tipping point which takes decades and decades to play out, and it's still a valid tipping point. There's a inflection point, but it's such that you can, so that the time scale is defined by the speed of the tipping point. I mean, the urgency, right? And secondly, there is a paper out by a collection of people, including a house father who mentioned at your previous meeting, dealing with reviewing all tipping points. He's very, he's in the Keith camp, it would seem, of it not overly concerned about tipping points. And I wonder if you'd read that, or if you have any counter. I guess maybe this paper in Nature by the people who came up. Anyway, if you have some recommendations, one or more recommendations or review papers on tipping points in general, that or enumeration of them, and the timescales and urgency on that from a scientific perspective, sort of a peer-reviewed review paper, I'd appreciate it. Thanks.
Isn't Lenton its recent paper the most Tim Lenton?
Yeah, could you put at least the authors in a
they have a new one out that goes into even and I don't think he's the primary author. He's one of the authors. Brian, do you want to?
Yeah, I think David wasn't reflecting. I mean, the most concise and articulate description of tipping points, I think, was done recently by the executive director of the Potsdam Institute, which during the introduction video of the World Economic Forum said fundamentally, not only dealing with tipping points, we're dealing with coupled tipping points. And he went from the Arctic to the Antarctic and all the way across through the equator, saying these tipping points are not only happening, they're coupled. And this the whole framing so far that
who was that person? Who presented that, if you don't mind? What was the name?
Right.
The name?
There's McKay. I'm pulling up a McKay here. I'll put the link in the chat.
And just go to the World Economic Forum site, and one of the prime videos shows the Potsdam Institute introduction on coupled tipping points. And I think we can refine that and then come back with a more precise set of questions for David to really explore this conservatism more.
Well, I mean, somebody can interrupt me if they had a point to say. But this is Greg Slater again. And I'm sorry, but I was not satisfied with David Keith's response to my question, which was really a different angle, which is that I just want to see what are the criteria we have to meet by the scientists, by whoever who opposes currently doing an in situ test on the global scale. And what I'm proposing, and I don't think it's particularly original, is an Antarctic pulse test. And he said, well, he said you can't measure the effect in terms of global temperature increase in such a test. That's fine. He spent the time in answering just describing why it was useless to try to measure the temperature effect, and said you should measure all these other things. Well, that's fine. But I mean, first of all, so his opinion that it's basic physics that you couldn't measure it. Well, that's why you do experiments, because it works out. Sometimes you get some surprises. And secondly, it's all the other things. I mean, there's been an enormous number of papers saying there are these unintended consequences on the unequal distribution of the effects of SAI cooling. And so this would be the first test to measure some of these things. And even if you don't get a temperature response, which it's not clear you wouldn't, it depends on how much you put up there, but you could actually start to see the predictions, where the predictions are taking things, and compare it with models, which they haven't done. But what I'd like to get from his perspective, not what he thinks the political community will allow, but from his perspective, what would it take for him to back such a test? How much instrumentation, exactly what would it take? Because right now it's, maybe sometime in the next 1,000 years we'll do a first test, but we got to do a million high performance computer simulation. When he talks about supporting research, he's really talking about modeling, or maybe in laboratory experience. He's not talking about tests. He mentioned maybe 10 years out. So I just wanted to nail him down on exactly what we have to what we have to do to satisfy him. And then he says, let's do that test. You've got it. You've nailed it. I can't get that from anybody. Anyway, that's what I wanted to hear of him. Instead, he told me why you'd never measure temperature. But even though he doesn't know that.
Gregor, if I could just, I think he does support actual experiments, not just lab. Like the Scopex thing.
Exactly.
Well, like Scopex, like just
Scopex is nothing. It's like make sunset.
I basically agree with you that this idea that there's going to be some magic point where, all the risks are resolved, and then we should go do implementation is kind of silly. Let me just finish.
Okay.
Let me just finish. So this is part of the reason, and I'm glad you raised this, because this is part of the reason many of us have been saying, well, why don't you just start with pilot, programs in the pole, in the Arctic, or, and it's actually got to be 2 poles, is my understanding. And then, gradually scale up. And of course, continue research by all means. We all want research, but you're never, the atmosphere is, my understanding, is so complex that you're never really sure of anything until you actually try to do it in the actual real atmosphere, and you try and do it very slowly. And, this is Mike McCracken's, has been on this forever. So this is part of that idea. And I was surprised by how he just really was not open to that, which is the other, it's the Cornell people, it's another major SAI research group that is proposing this. So I must have stepped into, a big debate between them.
Okay, but let me just quickly respond to your statement. I mean, we're still talking about 2 different things. You're saying we start small, but you're still talking about an operational system that starts small and grows. And you say as you understand it, it would be at both poles. That's a choice. I'm saying I'm trying to get one experiment done. And after that experiment, you may look at the results and be horrified and say, never again, we'll never do it. I'm not saying that this necessarily, I think it's unwise to promote it as this is on a path to some end deployment system. I'm saying, I'm trying to get a test of the models. And you can't test the models in the laboratory because it's a global system. So, I mean, I don't think selling it as we start with this one and we double it and double it and double it until we're cooling the earth to pre-industrial, because that scares people off. But and furthermore, I don't think that I'm not asking David Keith to weigh in on what would it take for the politicians to back it. I'm saying forgetting about whether we could actually get permission from the powers that be, whoever they are. I'm saying, what do we have to convince him of? What conditions do we have to satisfy where he would be okay with? Not that he pays for it, or maybe he has a different one, but would he be okay with having this one-off test, which I say is a pulse test? In other words, you charge it, you let it decay, and then you measure the hell out of the results, and you read.
No, I think he would favor that, and I mean, well, he said SO2 is right now being sent up to the stratosphere in very small, tiny quantities. This is it's not nuclear radiation.
No,
right?
but I'm talking about
this is something volcanoes put up in millions of tons.
Right, but I'm talking about
on a regular basis.
Greg, can I just jump in? David said that he saw the biggest barrier as moral hazard reasoning, and I've been of the view that that thinking has got some sort of basic empirical mistakes in it. So I think that's another issue that we could come back to him. Like I feel, Greg, that because of these sort of massive political barriers, that the sorts of questions on detail about what type of tests are things that can be solved once there's the political permissions, which are currently absent. So I think working on obtaining those political permissions and I think that a focus on the moral hazard debate would be a really useful thing that we could come back to with David, as he suggested.
Yeah, well, the moral hazard goes away when you require Scope 3 and Scope 4 decarbonization, and that should just be the preface to all of our conversations. And then that moral hazard is not there. I mean, not only do we have to eliminate emissions, but we have to draw down 2,400 gigatons of carbon dioxide, and then we have to repair the planet enough to get back to a healthy climate on a time scale that is faster than what we can actually remove.
Well, I mean, again, to answer Robert, the moral hazard, well, that's an infinite debate that can never be solved because everybody's got a definition of the moral hazard. But we do need to test the models. I'm just saying, we freaking do need to test the models. And if you do one test, I'm not talking, again, ScopeX is irrelevant to this because it puts out a kilogram. I mean, come on. I'm talking about a serious amount of SO2, but nonetheless, stuff above the Antarctic that would be gone in a year anyway. And after that, nobody would know it happened. So it has no moral hazard. Any more than Make Sunsets has a moral hazard, or ScopeX has a moral hazard, because it's totally innocuous. And
the moral hazard of ScopeX is the slippery slope argument that once you recognize the legitimacy of albedo enhancement as a climate response, then you're diminishing the pressure for immediate decarbonisation of the economy.
Well,
so,
but I just want to make sure that my question to Keith was not to analyze whether the Sami can be made to agree or whatever, because but I'm just saying, what would he, I mean, if all that stuff aside, right now, as far as I can tell, any test that I'm talking about in his mind is 10 years out, 10 years minimum.
Okay, let's, thanks, Greg. Let's hear from Ben. Unmute, please, Ben. Thank you.
Yeah. Looking at the article that was put in the chat about multiple tipping points happening at 1.5, it seems to me that is kind of a back in 2015, the IPCC predicted that horrible things would happen at 2.0 and really, really, really bad things would happen. I'm sorry, not so bad things at 1.5. It seems to me that we're recalibrating now. It seems to me that bad things are happening worse at lower temperatures than we expected. So I propose a slogan that says 1.5 is the new 2.0. What do you think?
Well, it's too much. We need to get back to 0.5 is, I think is the goal. But then the question, how do you do that? Like, do you start off by albedo enhancement and then slowly remove the greenhouse gases, or do you just rely on the greenhouse gas removal?
But like if David was implying that he didn't think 1.5 was so bad.
That's right. Which
any worse than it was back in 2015, and I think scientific evidence is showing. Now, I'm not sure because I'm not the scientist, but it's showing that based on the experience that we've built up in the previous 8 years, between 2015 and now, is that things are progressing more quickly than we would have expected for the temperature that we're at. Isn't that true? I think that's what
so a precautionary principle would say we need to prevent warming of 1.5, and the only way to do that is albedo enhancement. But that's excluded.
I'm not even going to albedo enhancement first. I'm saying let's get people on this page that 1.5 is as bad as we used to think 2.0 was going to be. Then we can talk about.
And we're not going to get to well below 2.0 either. That's what we're nowhere near there.
Right. Well, that's the second point. So 1.5 is the new 2.0. We've set the thermostat already to 2.5 or whatever. Now let's talk about what to do about it. That's it.
All right, we've come to the end of our time. So thanks very much, everyone. And I'll invite the HPAC steering committee to remain on the line, and we'll finish up there. So thanks so much for joining the meeting.
I appreciate your getting Keith on, and I thank you for letting me attend.
Thanks, Greg.